Okay, so how does changing the value of b affect the graph of an equation in the form y equals mx plus b? So we had Ashley, Alexandra, and Kiona guess, and Donnell. You better make a guess. Come on. Donnell, all you have to do is either type steeper or shift it up or down. So what you can do, Sarai, is, did I say it right this time? Oh, so that's good. Kind of. Wait, say it one more time for me. Sarai.
Yeah.
Sarai. You guys can have to correct me if I'm saying that wrong the whole time. So what we're doing is you can pick a notepad, like you could be student 5, and you can just start typing in there. Hit like the T button, I think will, do you guys hit the T button usually when you start? Or no? Actually, or do you just start typing? I think you have to hit the T of student 5, and then, so try typing your name in there. Oh, good, Donnell, thank you. You made a guess. I'm so proud of you. Nice job. Nice job. Okay, oh yeah, perfect. So Sarai, you don't have to guess if you don't want to at this time. We're going to go through it, but normally that's what I'll do is I'll put some notepads on the bottom, and then you guys can guess. And we took a survey too at the start, and so sometimes maybe I'll do a survey for you guys. And then there's a chat box on the right, and with the chat box you can also type to me too. Okay, so you guys, let's look at your guesses. So Ashley, you said the B represents the y-intercept. This is true. So by changing the y-intercept, it will change the answer. Okay, and the line downward. Okay, so you're almost correct. So the only thing is that there isn't an answer with the linear equation. It's just a line. So what it does is when you change the y-intercept, it does change the line up or down, depending on what it is. So that was good. And then Alexandra, you deleted yours. I know you said it was steeper, but it's okay because you know what? Steeper is why we talk about it. So the steeper would be the M, which is the second question. So we won't do the second question because I just gave it away. Kiona, if you change, you underlined yours. Very nice. And you guys can do colors too. Although I don't see, they're kind of small right now, so the colors might not be visible. But anyway, if you change the B, the y-intercept changes. And if you change it from positive, okay, somebody has their speaker on, to negative, the equation will decrease. Donnell, is your speaker on? Hey, Donnell, is not? Because there's somebody over there. I think it has to be there. So let's do this, because now we're echoing. I'm going to mute all of you guys real quick. Okay, there, that's better. All right, so anyway, so it changes it. Okay, so so if you change it from positive to negative, the equation will decrease. If changing from negative to positive, then the equation will become positive. B determines if the equation will be positive or negative, and the graphs line will go up or down. Kiona, that was very good. Very long answer. Nice job. Little essay go on there. So Kiona is exactly right. It moves it from up or down. And the only thing is that when you said if you change it from positive to negative, the equation will decrease. I'm assuming you mean that the equation will drop down. Is that what you mean? Okay. So it would be correct if you changed it from the y-intercept from a positive to a negative, the whole equation will drop down lower into the negative quadrant. And if you change it from negative to positive, the whole thing will go up into the positive requirement. Good. And then Donnell, shifted up is good too. It's either shifted up or shifted down. So depending upon what the y value is. If it's a plus y, it shifts up. If it's a negative y, it shifts down. And then Sarai. Never gonna get it. Okay, so does that make sense how we do those? Okay. So then we basically answered the second one. How does changing the value of m affect the graph of an equation? Well, m is just your slope, so that tends to make it either steeper or less steep. Okay? All right, you guys, any questions on that one? You can't hear me? Oh, really? Can you guys hear me? All right, let's check. Oh, I see why, because my speaker's muted. Okay. Donnell, can you hear me now? Okay, good. I muted myself on accident, sorry. Okay, so then let's actually move on. All right, so Last thing we're going to do, and then we'll do a quick review of graphing inequality since you guys all said that you were interested in that. And like I said, this is a short webinar today just because of the October 1 stuff. So we're just going to do a quick interpretation. So bamboo can grow very quickly, and this graph models the growth of a bamboo plant. And what you want to do is find the point where the line crosses the vertical axes. What does this point tell you about the bamboo plant? And then we're going to find the slope of the line, and then we're going to determine what the slope tells us about the bamboo plant. So first things first. Okay, you guys type in your pods. Where does the line cross the vertical axes? What are the coordinate points of that line? Okay. The coordinate points of where the line crosses the vertical axes. Can you guys see that? Is it too small? And you can make it. So Kiona's off and running. Got an answer. Okay, so by coordinate points we mean x and y. What are the x and y coordinates of that point? So that will be number 1. Okay, Sarai. Good, Donna. I kind of did it. Good. You've got a guess in there too. Donnell, Ashley, what about you guys? You do too, Ashley? Oh, you're just all the way down. Here, let me scroll down and find you. Ah, perfect. Okay, Donnell. Oh, and Alexandra. Okay. So while you guys are finishing in the last thing, the point where the line crosses the vertical axes, that is your y-intercept, right? So the y-intercept is where the line crosses, which is right here. I'm going to make a point there in pink, where it crosses the vertical axes. So, Alexandra, no guesses for points? Point. Donnell shifted up is still the old one. Okay, Donnell, remember participation is important for your grade. Okay, good. So you guys are all on the right track. So good, led by Kiona. So the point right there is 0, 20, and that is exactly right because you go 0 for x, but then you go up 20 for y. So what I want you guys to type, you're going to type some words. What does that point mean then about the bamboo plant? What is it 0, 20? What does that tell us in words? All right, Donnell, you're typing. That's good. Okay, you don't need to do 0, 20 more, but tell us. What, Kiona? Oh, you're telling me already? No, type it. Type it. I'm giving you guys typing practice. Oh, Kiona, did you raise your hand? Did you have a question? No? Oh, I thought you raised your hand. Okay, so good. Kiona's typing. Ashley, type in the thingy. That's not the thingy. Go back. So what I want you guys to analyze is what does that mean? What does 0, 20 mean about the bamboo plant? So give it to me in like real life. If somebody showed you this chart and this represented, right, there's height and then there's time. What does that point 0, 20 mean? Tell me what it means. Because really, what is the point of doing math, you guys, if we don't know what it means? Okay. And bamboo does grow really quick, by the way, and if you plant a bamboo plant and then you try to get rid of it, never happens. It just keeps growing and growing and more grow, and then you've got bamboo all over the place. It's crazy. Just telling you guys, I had bamboo once when I was little. We could never get rid of it. Okay, so we have some answers. So Sarai, and I'm just totally butchering that, but it's close. He's got some answers for me. Good. Kiona, nice job. All right, Ashley, Donnell, we're just waiting for you. Alexandra. I'm like, oh, sorry. Okay, you guys. I know I can't see what I look like on here because I have the other one up, so just tell me if my face, if I'm way out of focus. Somebody type me a chat. Donnell, what is behind you? Yeah. Help me out, you guys. Help me out. Oh, that's an office, Donnell. That's an office. Okay. Yeah, you guys, make sure. I'm going to move this back more. How about that? Yeah, tell me, you guys, if some strange things on the screen there. Donnell, where's your guess? Alexandra, keep going. You're doing fine. Don't be afraid to guess, you guys, because that's what we're here for, just to help us all learn this. And you guys, we really haven't done a lot with this anyway, so it's just good to think about. Okay. Donnell, you can always think of something. All right, Alexandra, good. Awesome. Okay, you guys, good job with your guesses. You guys are all doing a great job. Okay, so let's go through what you guys said. So Ashley, we'll start with you. The bamboo is already grown at 20 feet. Okay. And then Alexandra says it shows how long it took to grow. Okay. Kiona, at 0 days, the bamboo is 20 feet. And Sarai, the bamboo plant height is 20 feet. Okay, so I would say you guys are all have good guesses, okay? So let's look at Kiona's, and then we'll look at Sarai's, because those are, so Kiona says at 0 days the bamboo is 20 feet. So I want you guys to notice that she uses days in her answer and height, right? Feet. Okay, now look at Sarai's. Sarai says the bamboo plant height is 20 feet. So that was good because you used the height. You're only missing the time, and then your answer would be perfect. And then Donnell, you said 20 feet. Okay, so we need a little more explanation. So when you're explaining, you always want to have some words. Alexandra, you deleted yours. I can't see it. And then don't be afraid. And then Ashley said the bamboo is already grown at 20 feet. So you guys at least got the 20 feet. That's really good. But when you describe it, Kiona, you had it right on. Basically, at 0 days, the bamboo is 20 feet tall. So at 0 days, right? So maybe when you're first planting it, at 0 days, the bamboo is 20 feet. Okay. So nice guesses, you guys. Good job. Very good. Is that how you spell bamboo? Is 20 feet. Okay, good job. Okay, so number 3 then, let's move on. It says, find the slope of the line. So who can really quickly calculate the slope of that line? You can just look at it and find it. You don't even have to do any math calculation. So who can do the slope? Okay, good. Awesome. Say that one more time, Kim. Put your guess, whatever you think. You're on the right track. So you guys remember slope is rise over run. That's your hint. Ashley, did you put on there? Oh, okay. Good job. You made a guess. Very nice. And Kiona is typing. Alexandra. Have you done much with slope? Not so much. That's okay. That's all right. And you know what? You started, you guys recently started, so you probably are like, I don't know what Miss Elliott's talking about, and that's fine. That's okay, Sada. You'll get it. It'll come back to you. It'll come back really fast. You'll be surprised. And that's why I say sometimes when you're watching the lessons, then suddenly you might get it. Be like, oh, I get it. And then go through. Okay. So Donnell, no guess. Alexandra, no guess. Okay, and Sarai. Okay, so let's look at Kiona's then. At 0 days. Oh, no, wait. Kiona, what was your guess? Oh, there it is. Over 5 squares, up 2 squares. Good. And Ashley said 2. Is that up 2 or over 2? Up 2. Up 2. Okay. So you guys are looking at, now if I look at this, so Ashley, it looks like you went 1, 2, up to 40, right? And then over 1, 2, 3, 4. So that is correct. And then Kiona, what did you say? You went over 5 squares, up 2. So you went 1, 2, 3, 4, 5, up 2. So you're off of this a little bit. But you both are, so you meant probably over 4, up 2. But let's think about slope, you guys. So you guys are both on the right track when you are talking about going up and over. But remember that slope is our rise over our run, right? So to get to our rise, we want to do, and this little triangle is a delta, it's a Greek symbol, and it means the change. So we want to look at the change in y over the change in x, okay? Sometimes people write that as, and it's in this week's or last week's lessons, y2 minus y1 over x2 minus x1. Does that look familiar to you guys? Okay. So let's look at the change. So we can go from this point to this point. I'm going to make a point on the graph right here. Or we could even go up to this point, which is what I think Kiona, you and Ashley were trying to do, right? Okay, so the only thing is you guys are on the right track counting grids, but here's the thing. How many feet is one grid? 10, good. So we go up 10, 20 to get to 40, right? So be careful not to count it as 1, 2 because it represents, each one represents 10 feet. Now let's go the other way. So how much does each grid represent if we go over? So like if I go from here, 0 to here, 5, perfect, exactly. So that would be the only thing is be really careful about that. Now if I go between these 2 points, these close ones, I won't have to reduce. So if I go up, we just said that we went up 10, right? And if I go over 5, 10, we go over 10. Oh, because here, that's actually 30. So here, I don't want to confuse you. Let me I'll write that as 30 here. And the difference between 20 and 30 is 10, and that's where I got the 10. So let's just put a 30 here so that we know. And then we'll just go this way. So if I go over 5, 10, and then up, I've gone up 10 feet, and I've gone over 10, 10 days, or whatever that is. There we go. Where's that? Okay, so if I think about my slope then for this, what would I put up on the top for my y? How much did I go up? 10, good. And then how much would I put for my x? How much did I go over though total? How many days? 10, good. So you guys, here's how the slope is, right? 10 divided by 10 is just 1. So it went up 1 foot every day. It grows 1 feet every day. So can you guys imagine that with a plant? That would be a very fast growing plant. 1 foot, you wake up the next morning is another foot tall. Kind of crazy. Don't plant any bamboo. That would be a crazy plant. All right, you guys, good job. So I just want to conclude today's webinar with a quick kind of demonstration of how to graph inequalities, because you guys mentioned that, and then we'll be done. So we'll just do, is that what you guys are meaning, is on a grid like that?
Yeah.
Okay, so let's just do a couple just real simple ones. So let's say this. So we'll do them in standard slope-intercept form. So inequalities will always have something like that, right? Less than, greater than, less than or equal to. So let's do y is less than, we'll do 3x minus 4. Okay, so always graph this like you normally would. Our y-intercept is down here at -4, right? That's the b we talked about. Our slope is 3, so we count up 1, 2, 3 over 1. And now I just need to put a line, a boundary line it's called, through that. Does anyone know, will I put a solid line or a dashed line? Okay, so solid, you think solid? Any other guesses? Guesses? Okay, so Ashley, good, thank you for guessing, that was actually good, because nobody else is guessing. Okay, so you guys, anytime you just have a less than or a greater than, that is actually a dashed line. So at least you made a guess. So you guys, that's going to be a dashed line. It's only going to be a solid line if it says less than or equal to or greater than or equal to. So if I make a little note for you guys, right, if it's a less than or equal to looking like that, or a greater than or equal to looking like that at the top, can you guys see that? Is it not showing up? There it goes. Then that is a solid line. So we'll write solid in there. If it's just a less than or a greater than, that's dashed. Okay, and there's a lesson on that too, so when you get to it, just be careful to take notes on that. Okay, now the last thing about this is we have to shade it. So this says that we want all the y values that are less than this function. So where is it less, above or below? What do you guys think, above or below? Alexander, what do you think? The y values that are less than that line, are they below the line or are they above the line? Okay, so let me ask you this question. Here's a y value right here at 2. Is that greater than this line or less than the line, where the line is? Think of the line as a boundary, like a wall. So as you go up, are these y values bigger than where this line is? Yeah, yeah, good. So then if you look down below, are those y values going to be less? Then where the line is? Exactly. So we want all the, see how this inequality says less than right here? So we want all the y values that are going to be less than that line. So we want all these values here. So that's how we would shade. Make sense, you guys? Okay, let's do one more. How about, I'll do one final one. How's that sound? You guys doing okay? Okay, so let's try one more. So let's do like this kind. So let's do y is greater than or equal to, we'll do this, 1/2 x plus 3, how about? Okay, so I'm going to graph it. So 3 is my y-intercept, so that's where I make my first point. My slope is 1/2, so I go up 1 over 2, and I could do it again if I want. Oh wait, am I going the right direction though, you guys? No, how come I'm going the wrong direction? Ah, yes, I'm doing a negative slope, but my slope is positive, so always be careful about that. So up 1 over 3, up 1 over 3. Good. Okay. All right, you guys, solid or dashed line? Solid. Good job. So I'm doing a boundary line, so I always want to do my boundary line so that it goes all the way through the graph, because that's kind of separating the graph into two parts. So that's why it's called a boundary line. Now I just need some shading. So who wants to tell me, am I going to shade above the line or below? Do I want the y values above or below? Yes, Kiona, very good. Above, because it says y has to be greater than or equal to. So you guys see how this is? These y values here are greater, so that means I shade all the values above. And the numbers on the line are included. That's why it's a solid line. Okay, all right, you guys, type in there if you have any questions. Any questions at all? Uh-oh, almost died. Asher, are you typing to me? Uh-huh, I see. Okay, you guys, do this before you leave then. So everybody give me go to the little hand raiser guy and do a applause. How about that? Do an applause. Hey, applause. If you click on it, do you guys see an applause button? There's a little guy at the top that has his hand up like that. Do you see? So you can do an applause. See if you guys can all do an applause. If you do an applause, you get to be done. So you guys are all doing applauses except Alexander. Why did I shade up above?
Yeah.
Oh, because it says I want all the y's that are greater than. See how that's a greater than sign? So I want to shade all the y's that are greater than this function. And up here, these are all greater. So that's why I'm shading above. Okay, did everybody raise their hand? Yay. Okay. All right, good job, you guys. Any other questions then? Anything at all? Don't be afraid. All right. Hey. Well,